Hello students, welcome back. Today we are going to study the final chapter of Software Requirement Engineering. The title of this chapter is Solution-Oriented Requirements. Let's look at the course learning outcome. At the end of this topic, you should be able to describe the three modeling perspectives for solution-oriented requirements. These three perspectives are, number 2, data perspective, which you will use entity relationship modeling. Number 3, from behavioral perspective, in which you will use UML state machine diagram. And finally, from functional perspective, in which you will be using event-based partitioning data flow diagram. Along the way, you will be also learning other diagrams which are related to these three perspectives, a part of ER modeling, UML state machine diagram, and event-based DFT. In the first part of this lecture, I'll do introduction and then to cover on the data perspective of solution-oriented modeling. Let's begin. Let's model requirements using graphical models. A picture is worth a million words, so the saying goes. If we can model requirements graphically, it is very easy to communicate and to capture the details graphically. Now, let's look back the overall pictures of our studies. The requirement artifacts that we have been learning are goals. Goal is the statement of expectations or requirements given by our client. To understand the goals, so that we can narrow down to the objectives, we need to have examples. These examples are called scenarios. Scenario is a sequence of interaction steps that documents an example of the goal's fulfillment or non-fulfillment. For example, fulfillment is when you successfully execute a task. Non-fulfillment is when a task is improperly executed. Let's use the ATM machine, auto teller machine. When you successfully have your PIN number authenticated after inserting the bank card, you get to the main menu, you're able to withdraw the cash successfully. That is a fulfillment scenario. On the other hand, if the PIN number that you entered is incorrect, resulting the access being rejected, that is an example of non-fulfillment scenario. We need to have both fulfillment and non-fulfillment scenarios. Next, we'll be looking at solution-oriented requirements. Having understood the scenario, solution-oriented requirements have three perspectives. They are data, functional, and behavioral. It also includes the quality requirements and constraints. Let's look at the graphics on our left hand, on the left hand side of the slide, the bottom graphics. It shows how the three artifacts differ from each other, from one another. On the x-axis is the amount of solution, how much details, shows whether it's complete or not. The y-axis shows agreement of the content. Let's begin with goals. Goals has less details. It's a general statement of requirements. And the views may be different. If you ask the top management, if you ask the people on the ground, there will be different views of the same goals. Examples are more concrete. Examples offer more details. Examples is clearer. Solution-oriented requirements has the most number of details. It provides the consolidated view. Solution-oriented requirements is an artifact that a requirement engineer will come up with, having analyzed the goals and scenarios. Thus, it is obviously should be containing more relevant details, providing more consolidated view as compared to scenarios and goals. Solution-oriented requirements, or SOR for short, is based on structured natural language requirements. I'd like to bring your attention to the figure on the bottom right. Look at the triangle. In the center of the triangle is the requirement that you have acquired through requirement elicitations. These requirements are best structured using structured natural language. Now, this requirement can be analyzed and transformed into solution-oriented requirements. We would have thought that for the same requirement, there should be only one solution. That's true. But that one solution will have three perspectives: for ease of analysis and for ease of design later on. The two perspectives are data, behavioral, and function. The data perspective can be represented graphically using data model. The data model that we are going to study in this lecture is entity relationship diagram. The other perspective is behavioral perspective, which is best documented using behavioral model. State chart, UML, state machine diagrams are two model languages or model notations that we'll be exploring later on in the following lecture. And in the final lecture, we'll be looking at functional model, which represents the functional perspective of the requirement. There are many techniques to come up with data flow diagram. We'll be learning some of these techniques with special emphasis on event-oriented data flow diagram. How is this solution-oriented requirement related to requirement engineering? Please look at the figures on the left-hand side of the slide. If you recall earlier, requirement engineering has three objectives. Number one, to ensure that the requirements functions, requirements, qualities are completely captured with sufficient detail. The content should not be vague. The content should be complete and detailed. The requirements should also reach agreement, whereby it no longer be holding individual views, but rather consolidated views. A set of consolidated views have minimal conflict and provides the intended solution. Last but not the least, requirements should be documented. Documentation ensures that the requirements are compliant with guidelines of the system design, and it's a good software engineering practice. Now, this is the one that we are focusing on. Solution-oriented requirements ensure the documentation, I repeat, solution-oriented requirement ensures that the documentation is compliant with guidelines. And in this case, it should have three perspectives, which are data, behavioral, and functional, using the correct notations. The next slides will be on data modeling language. Data modeling language covers the data perspective of solution-oriented requirement. Data models specify the structure, the static aspects of the system. The structure includes the entities, the classes, the objects, the relationships between these entities, i.e. relationships between classes, relationships between objects, and the attributes of the classes that these objects belong to. Recall object-oriented design. Data model instances, i.e. objects, provide concrete entities and relationships which can be used to identify entity types and relationship types for the data model. If you recall, in requirements scoping, we need to identify the context, the system context, and the system boundaries. The objects that we need to identify are the objects within the system boundary and the objects in the system within the system context boundary. Now, these objects are examples that we can gain from scenarios. By identifying, classifying these objects, we can identify the class type of these objects. Objects are instances of class. Data model, if you look at the figure on the right-hand side, concrete objects at the bottom, when you identify the class, you get the data model. Data model, hence, is the definition of entity types, relationship types, and attribute levels for the system. To represent the model, we need a suitable language. And the language that we have chosen is graphical in nature. There are two modeling languages for data. There are entity relationship diagrams model and UML class diagram. In this lecture, we'll be looking at entity relationship diagram instead of class diagram. But I hope, as a pedagogy of this lecture, you're able to relate how ERD and class diagram are mapped. If you recall the database lecture, ERD has been extensively used for modeling the tables used in the database. See you later.